All right, everybody, we are back, and we are talking in this video about information from section 5.9 of AP Calculus, connecting a function, its first derivative, and its second derivative. So what we're going to do is we're going to look at some of the relationships that exist between functions and just kind of tie things together. We've talked about a lot of information in the last couple of lessons, and in this lesson we're going to kind of tie everything together while looking at some graphs and doing some examples connecting all of these things together with one another. So let's start with example 1. What relationships can we see between the graph of this function and its first derivative? So we're going to start on this page by looking at the relationships between this function and its first derivative. On the next page, we're going to look at the relationships with the function, the first derivative, and the second derivative. But for right now, we're pretty much just going to ignore f double prime over here. And we are going to look at and focus on these two graphs to the left. Okay, and we're going to organize our information in a little table here. So, here's what we're doing. We're looking at what happens when f of x possesses a certain characteristic. What does that tell us about f prime of x? And the first characteristic we're looking at for f of x is when f of x is increasing. So if you look at the graph of f of x, we're going to look at where it is increasing. And it increases from right here to right here. I'm going to go ahead and highlight that yellow. F of x is increasing there, in between a and b. And so, when I look at the graph of f prime, and I see what happens in between a and b. What is true about the graph of f prime when f of x is increasing? Well, the graph of f prime is entirely above the horizontal axis, which means that when f is increasing, f prime is greater than 0. Okay? And there's how you see that relationship in these two graphs side by side. What about when f is decreasing? Now we should all know that f is decreasing right here to the left of a and also here to the left of b. If we look at this graph to the left of a, to the left of b, what all of those values have in common is that the derivative is below the axis. And so it is decreasing when f prime of x is less than 0. Okay, next. When f has a relative maximum, so that happens right here at b, what happens to the derivative at b? Well, the derivative at b changes from being positive to the left, and then it is negative to the right. So when we have a relative maximum, f prime of x is greater than 0 to the right, then f prime of x is less than 0 to the left at our relative maximum for our function. And one last thing, what happens when f of x has a relative minimum? That's going to happen right here at a. And we have a similar scenario to the left of that. F prime of x is negative, but to the right, f prime of x is positive. And so, f prime of x is less than 0 to the left when we have a relative minimum. Then f prime of x is greater than 0 to the right. That, of course, all ties back to our first derivative test for extrema. And that's all stuff that we have talked about before in that context. We're just kind of putting it all together here. All right, let's go over to the next page. Excuse me. And we'll talk about these derivatives in example 2. What relationships can we see between the graph of this function and its first and second derivatives? So we're going to tie these things up a little bit differently here. First off, where f of x is concave down. If we look at the function f of x, looks like it is concave down from about midway between a and b on. And so we'll highlight that point. Sorry. And it looks like that's right there. So those are the three pieces that tie together with one another. So where f of x is concave down, what's happening with f prime of x? F prime of x, where it's highlighted yellow, well, some of it's above the axis, some of it's below the axis, but on this entire interval, the slope of f prime of x is negative. In other words, f prime of x is decreasing. And if we look at the graph of f double prime, the entire yellow highlighted area, f double prime of x is negative. So those are the relationships that we've observed thus far with a graph when it's concave down. And there you can see it in action in all three graphs simultaneously, what it looks like. I'm thinking the next thing we're going to talk about is when it's concave up. There we go, when it's concave up. Okay, here's where the graph of f of x is concave up. There's where it is on the f prime of x graph. There's where it is on the f double prime of x graph. And so we see what's going on here. F of x is concave up on that interval. That's when f prime of x is increasing. And f double prime of x is positive. All right, how about our point of inflection? Our point of inflection is right here where this graph changes concavity. It's right there on f prime of x and there on f double prime of x. Okay. So here, a point of inflection, f prime of x changes from increasing to decreasing or vice versa. In this case, it changed from increasing to decreasing, but we could also have a point of inflection on the opposite. We might also say that f prime of x has a relative max or min. At a point of inflection. Okay. And then f double prime, looks like f double prime is 0 there, but what we really want to say is f double prime changes sign from positive to negative or vice versa. So those are all the things that and relationships that we should be seeing between functions and their first derivative and their second derivative. All right, let's go ahead and we'll bust through example 3 here. For the function f of x equals 2x cubed plus 4x squared plus 2x, use a table to help you organize your information and draw conclusions. All right, so the first thing I'm going to do is I'm going to take the derivative of this sucker. I'm going to slide my screen up a little bit so that it's not such a reach for me. So f prime of x is equal to 6x squared plus 8x plus 2. And the second derivative is going to be 12x plus 8. For this first one, I'm going to go ahead and factor out a 2. I'm going to try and factor this 3x squared plus 4x plus 1. I think that's just 3x plus 1 times x plus 1. Yes, it is. So there's my first derivative factored. Okay. So f prime of x is equal to 0 for x equals -1 and x equals -1/3, and f double prime of x equals 0 for x equal to -2/3. And now I'm going to organize this up a little bit using my table here. I'm going to talk about what happens when x is less than -1, when x equals -1. By the way, just so that everybody's following why I'm putting these numbers on my chart here. And then next, I'm going to look at what happens when x is between -1 and -1/3. And then when x is equal to -1/3, and then when x is greater than -1/3. And again, highlight, this is all because of that piece there. And for the second derivative, I'm going to analyze what happens when x is less than -2/3, when x equals 2/3, and when x is greater, -2/3, and when x is greater than -2/3. Okay, so for these values, those were where I found it was 0. All right, now, to the left of -1, let me pick a value, -2, and substitute it into my derivative. That's 2 times a negative number times a negative number, so it's going to be positive on this interval. And then I pick something between -1 and -1/3. This is almost like a sign chart, but a tabular organization, very similar. I put -2/3 into my function. That makes that negative. That's positive, so the product of those is going to be negative. And greater than -1/3, let's put 0 in there. That's 2 times 1 times 1. That's positive. Okay. And then for the second derivative, if I put -1 in here, into the second derivative, it's negative. And if I put 0 into the second derivative, it's positive. And so there I've got my first derivative and my second derivative organized. The question I'm trying to answer here is, when is f both concave up and decreasing? And if I kind of combine these two into one big chart, we've got where x is less than -1, where x is equal to -1, where x is between -1 and -2/3, where x is equal to -2/3, where x is between -2/3 and -1/3, where x is equal to -1/3, and where x is greater than -1/3. Okay, so that's going to get us all of our information. First derivative was 0 here and here. Second derivative was 0 here. To the left of the 0 here in the second derivative, all of these are negative. And to the right, they're all positive. And to the left here, this is positive. To the right here, this is positive. And in between, these were all negative. In between -1 and -1/3. So we're looking for where it's concave up and decreasing. So that means we want f double prime greater than 0 and f prime less than 0. So let's find f double prime greater than 0. That's all these here. And f prime less than 0, that's these values here. And so my interval where this is both concave up and decreasing is on the interval from -2/3 to -1/3. And that's the answer to my question. All right, we're going to call it quits with this video, and we'll come back in the next video. We'll do a second video on this unit and just do a little bit more information and a couple more examples, and then we'll be done with section 5.9. All right, have a great rest of your day, everybody, and we'll see you next time.